Hello everyone, welcome to the series of short tutorials on how to use an HPC. Over the series of these tutorials, we'll go over the basics of an HPC, the user interface and how to run and monitor your jobs on the HPC. So let's begin. To start with, what is an HPC? Well, simply put, an HPC is a huge amount of computing resources all clubbed together in order that we can execute programs that are too heavy for our laptops, computers, or workstations to execute. Examples might include astronomical and biological simulations, or say a deep learning task that requires hundreds of gigabytes of data as input. However, the structure of an HPC is slightly different from our general everyday systems. This can be understood from this image in the left window. The HPC consists of a master node and several compute nodes. The master node is the computer where you log into when you connect to an HPC cluster. Once you log in, it will look like the terminal to your familiar laptop or PC. This is where you can test out your toy versions of your programs and submit main programs with the compute nodes. Now this brings us to the compute nodes. The Ashoka HPC cluster has 9 compute nodes, each with 104 cores. These are the actual nodes where all your heavy jobs and programs will be executed. Now let's move on and look at how the Ashoka HPC UI looks like. Let's log into an account. We log in using our user ID and the Ashoka HPC IP. Now we're logged in on the master node, and you can see that this looks like any other general Linux terminal. Now one question might arise is why not, just like our general systems, use the master node to normally run programs? Well, that's because each user on the HPC logs into the same master node and uses it as a platform to submit their tasks. If, say, I run a program on the master node that takes up to 20 gigabytes of memory, it will seriously hinder the ability of other users to carry out their tasks on the HPC. This is actually a very serious issue, and we have policies in place that can lead to one having their access to HPC revoked if such action is carried out, despite multiple warnings. So now moving on. In order to use the resources provided by an HPC, we will need to know a couple of commands. An HPC uses a software called the Portable Batch System, or PBS, whose task is to schedule the job submitted to it among the available computational resources. A couple of very crucial commands which you can see here listed out on the left are module avail, module load, module list, module unload, and module purge. We will see how these commands are used in the rest of the video. So let's start with module avail. This lists out all the available compilers or modules on the HPC. Now you might notice that a couple of these compilers have multiple versions of itself installed on the HPC. So why is that? Well, that's because different programs might require different versions of the same software. So having multiple versions of a compiler will allow for different programs and projects to seamlessly run and carry out their tasks. So how do we load, say, one of these compilers? Say we want to run a simple Python program and would like to load Anaconda. We use the module load command and append it with the full name of the compiler. Now Anaconda is loaded. To check this, we can use module list, which lists out all the currently loaded module files in our environment. Say we want to load another module file, say data. We can again do module load compiler. Now if we use module list, we see that data is loaded. Now if we'd like to remove data, we can use the command module unload and the full name of the compiler, and module list will reveal that data is actually unloaded now. Another way to remove compilers or say module files from your environment is the module purge command, which actually completely removes every loaded module file from your environment. So what exactly is module load doing? Well, it adds the path variable for a particular compiler or module file to your environment so that you can use it. To get some idea of how this is happening, let's look at our current state of our environment. You don't really need to understand anything here, just follow along. Now if we load Anaconda again, now you can just notice that we have Anaconda 3 listed out in some places of our state of the environment where initially there was nothing or Anaconda was not present. So this gives you some idea of how exactly module load is loading different module files to your environment and allowing your programs to use it. So now that we can load compilers and packages, we would like to get started on submitting our jobs. So in the next video, we'll talk about how to submit our jobs using a shell script and the QSub interactive mode. Thank you.